Welcome to Lesson 11 of Module 2, and the title of this lesson is Developing Rules for Multiplying Signed Numbers. And this first part here is going to be similar to what we did in class on Monday, in that it is using the analogy of the integer game, okay, and thinking of the integer game drawing and discarding integer cards. Okay, so here's part A, and in part A, well, actually, in this example here, we see the four quadrants. Okay, we've primarily been working in quadrant 1, where everything is positive. Okay, but now you see the entire plane here, which includes quadrant 2, 3, and 4, and that's how these quadrants move. Starting from quadrant 1, they're going to move counterclockwise around. Okay, so so we're going to actually work with all four quadrants, but in this first section here, part A, they just want you to complete quadrants 1 and 4, okay, and that's the right side of the table. Here's 1 over here, and here's 4 over here. So I'm going to work on this area and this area, and I'll give you a few examples to help you get started here. Okay, and it tells you right here, it gives you an example. It says complete quadrants 1 and 4 of the table below to show how sets of matching integer cards will affect a player's score in the integer game. So in this example, they've actually entered 6 right here. 3, that would represent 3 2s, increasing a player's score by +2, 2 + 2 + 2 equals 6 points. Okay, and very specifically, this x-axis right here equates to the number of matching cards. This is the number of cards that are being either being drawn or being discarded. Okay, and moving up this way here, this is the integer card values, and they only go from up here in quadrant 1, they go from 1 to 5, as you see, and down here in quadrant 4, they go from -1 down to -5. Okay, so go ahead and let's go ahead and do another one together. So if we said we chose 5, that's the number of cards. We chose 5 3s. Okay, so we chose 5 3s. What's going to be here? It's going to be 15. Okay, because 5 3s is equal to 15. All right, drawing 5 3s. So go ahead and fill in quadrant 1 and quadrant 4, and come back and we'll look at it together. Okay, so here's what the right side, or the right half of this table should look like. And if yours doesn't look like this, maybe you were confused for some reason, just go ahead and pause this presentation and make it look like this. Okay, and you can see it's more or less a multiplication table, both top and bottom. One very big difference, as you can see, the top yields products that are positive, okay, and the bottom, quadrant 4, yields products that are negative. Okay, this is something that we learned in lesson 10 in class. We have our positive here, positive number of cards. So that positive and times a negative, okay, if we're looking down here, okay, times the negative, in this case a -1, okay, is going to equal a -5. And we talked about in class, it's like drawing 5 1 -1 or -1 cards in the integer game. Okay, we made a distinction of having that positive value first and then that negative value, even though we know that math is commutative, so these numbers could be switched, the -1 first, but with the 5 first, it has that connotation or that relationship to the integer game where you are drawing or you're picking up that many cards. And in this case, you're picking up 5 -1 value cards. So anyway, yeah. So if you're again, if your table, oopsie daisy, don't want to do that. I'm going to have to go ahead and get that back. Okay. I just want to actually get rid of this here. So if yours doesn't look like that, please please pause and do make it look like just like that. One of the questions is this this first question. Well, let's just look right here. So in terms of what does this quadrant represent? So quadrant 1, what does this quadrant represent? And again, as I had just mentioned, and again, we're talking in terms of the integer game, okay? And where this is the reference, throughout this discussion of integers, is we are making that relationship to the integer game. So in this case, and again, you can write this down, and you can do the other side on your own later. But when they ask that question, what does this quadrant represent? And it represents, like I had just mentioned, it represents picking up, picking up or drawing, picking up positive value cards. Okay, positive value cards. So if you're in the integer game, you are drawing positive, and in this case, like right here, you would be drawing 2 integer 2 cards. Two cards is going to give you a value of 4. Okay? So then what does this quadrant represent? We're talking in terms of quadrant 4. Okay? Again, we're still picking up, okay, because this number here is positive. Okay, so we're still picking up. So now we are picking up or drawing, picking up negative value cards. All right. So in the case right here, we have picked up 2 -3 cards, which would yield us a value of -6. So that would be -3 plus another -3, which would equal -6. Or, as we see here, 2 times -3, which also equals -6. Okay, so there we go. And again, you can imagine, if you just want to imagine, and we'll do this though, but you can imagine what this side, okay, or this half of the table is going to represent, right? Let's just move on to the next. So we filled these in already. You have these filled in, but let's answer these questions down here. A, what patterns do you see in the right half of the table? Okay, are there any patterns that you recognize? And then B asks you, enter the missing integers in the left side of the middle row and describe what they represent. There goes my phone. Okay. Alrighty, don't just ignore the phone. But anyway, right here, this is what B is referring to. Okay. That B is referring to that. Go ahead and enter those missing integers, and what I want you to do is go ahead and describe what they represent. We talked about what these represented over here. Okay, so go ahead, and you don't have to fill these in because those are filled in already. Go ahead and answer A, and then go ahead and fill in those the left side of the middle row. Okay, come on back. Okay, so we're back here, and as you can see, I have filled in these 5 numbers right there, the 5 integers on the left side of the middle row, and of course they are all negative, -1. And again, if you think of this in terms, this would be 0 in the middle, pretty much. If you think of this in terms of a number line, positive on the right side, of course, and then negative on the left side. Okay, so moving into that, to this other side, this left side, all of our x values right there are, in this case, are going to be negative. and I described them as the number of matching cards discarded. Okay, when I'm thinking of the number of matching cards on this side, that's picked up, okay, or drawn over here. That's the number of matching cards that are discarded, okay, or removed, hence the negative value. Okay. Well, patterns that I saw on the right side of the table, the right half of the table, quadrant 1 is positive, pretty obvious. Quadrant 2 is negative, and the absolute values are reflections. Okay, so if you look at absolute value of quadrant 1, these are all going to stay the same because they're positive. Absolute value of quadrant 4 here, they would all be positive if they are talking absolute value. Okay, and they would be reflections of each other. So if we were looking in a mirror, these would be here. These 1, 2, 3, 4, 5 would be one right here, and they would be reflections. We can actually flip these up, and they would be in the exact same places. Okay. So yeah. So let's go ahead and continue this. Let's go ahead and look at quadrant 2. Okay. If you would go ahead and complete quadrant 2 of the table. Okay, that's right here. All right, so you can go ahead and pause and go ahead and fill in quadrant 2 and come on back. Okay, so quadrant 2, of course, would follow the similar rules. It becomes more or less a multiplication table. Okay, and it's going to look a lot like quadrant 4. Sort of in reverse in a sense. Okay, we're going to have -1 here, -2, -3, -4, -5. Okay, so this would actually be a true reflection of of quadrant 4. Not in terms of absolute value. So actually, I'm going to pause and just fill the rest of that in, and I'll be back. If you can, in the meantime, would you just go ahead and fill this in? Okay, so here is quadrant 2 filled in. I'm sure yours looks exactly like it. Again, looks very similar to quadrant 4 because we are multiplying negative value, which is right here, and which is the number of matching cards discarded, and this is the number of matching cards right here. So, and the question, what does this quadrant represent? And it represents removing positive value cards, whereas over here it was picking positive value cards. In that sense, if we had 4 and 3, it would have been 4 which problem I have, so 4 times 3. Okay, that would be right there. Over here, if we had -4 and 3, again, that would be -4 times 3. Okay, you can see as whereas this one would be -12, this one over here would have been 12. Okay. Alrighty, so yeah, so that's that. Let's go ahead and let me see. Let's go ahead and skip over to here. Let's ask some questions here in terms of quadrants 2 and 1. C asks you, what relationships or patterns do you notice between the products or values in quadrant 2 and the products values in quadrant 1? Okay, so why don't you go look at that. Look at 1 and 2. 1 over here, and then 2 over here. So go ahead and look at those and notice some patterns, or notice relationships between those two. Come on back. Okay, so when I look at those two, quadrant 1 and quadrant 2, in terms of absolute value, they are reflections on one another. So if we look here, using this center line right here, if you look in terms of absolute value, they are reflections. You can flip them both up and they would be in the same exact place, the same exact way as you would with quadrant 1 and quadrant 4, using that other line as your central point. Okay, so and here's D. D asks us this: what relationships or patterns do you notice between the products in quadrant 2 and the products in quadrant 4? Well, you notice they're all negative values, okay? And each product of integers in quadrant 2 is equal to their product of their opposites in quadrant 4, okay? So how do we write that? So let's write that each product of integers in 2, I won't say quadrant again because say quad is equal to the product of their opposites in 4. I'm sorry, this is really messy. I really apologize. And let's just look at that. So, for example, let me see, kind of clean this up here. So for example here, if we had, over here we have negative 2 times 3 is negative 6. But over here we have 2, which is the opposite of negative 2, times 3, again, is I'm sorry, I'm looking at the wrong place. Excuse me. Do that again. Here we go. We have negative 2 times 3 is negative 6. Now we have 2, which is the opposite of negative 2, times negative 3. Negative 3 is also negative 6. So these two values here are the same. The two products are the same. Okay? But they were derived from opposite integers. We had negative 2 and 3, and then 2 and negative 3. Okay, so negative 2 times 3 is the same as 2 times negative 3. Okay, so they are these products of opposites are fixed. Okay, and that was D here. All right. Okay, so here E asks you this. It says, use what you know about the products in quadrants 1, 3, and 4 to describe what quadrant 3 will look like when its products are entered. Okay, so go ahead and just write that down and come on back. Okay, so if you go back and look at the table without quadrant 3 filled in, you could see a couple of things. First of all, you see a pattern here building. So if you have quadrant 1 where all the values are positive, okay, and then you've got quadrant 2 where all the values are negative, okay, and quadrant 3 which we don't know, and then you have over here again in quadrant 4 where they're all negative again. So if you're thinking in terms of patterns, and patterns are very strong in math, you would expect that these would be all positive values, okay? And the way they would look, the way you see the mirroring of 1 and 4, they would probably be mirrored in the same way, okay? So if we were to go ahead and fill that in, I think we could be pretty safe to say it's going to look like this. 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 3, 6, 9, 12, 15, 4, 8, 12, 16, 20, 5, 10, 15, 20, 25. Okay? All right, yeah, and you can see, and again, if we were to look at this and we were to ask ourselves that question, you know, what does this quadrant represent? And you could see that it would be when you are removing negative value cards. Okay, so here we are removing negative value cards, and you know, this came up in class today, and it was a real shocker for one of our students in class. He was like, how do you remove a negative? It's already negative. And we talked about this idea of when do you remove a negative? You remove a negative when you pay off a debt to somebody actually in class. I mentioned that really good to hear you guys. It's all positive here. Good to hear you guys understanding some of this economics. Very important to get to know some of that early on. Yeah, so removing a negative is the same as adding a positive value. So if I get rid of $300 in debt in my bank account, that actually adds a positive value to it. I no longer owe that $300, so becomes a positive entry into my books. Okay, these last two questions here on Part C, after we have already completed the Quadrant 3. F asks, is it possible to know the sign of a product of two integers just by knowing in which quadrant each integer is located? Yeah, it is, because we noticed that we saw the pattern. Quadrant 1 is positive, because that is a positive times a positive. Okay, so a positive times a positive is a positive, and that's like similar signs equal positive values. Okay, and we saw that quadrant 2 is negative. Okay, because we have a positive times a negative, and when we have opposite signs, that yields a negative value. Okay, and then right here, quadrant 3 is negative times negative, and that yields a positive because, again, these are similar signed integers, and they yield a positive product. And then we saw quadrant 4 finally negative as well, because, again, it was positive times a negative. So you can see that pattern moving from 1 to 2 to 3 to 4. Okay, positive, negative, negative. Okay. Which quadrants contain which values? Gosh, we just went over that there. Okay. Integer game scenario. We've been talking about that, all along, throughout this lesson. Quadrant 1, it was we talked about picking two three cards, and that yields you 6. Quadrant 2, throwing away two 3 cards yields you -6. Okay. Over here, throwing away 4 cards, okay, -4 cards is going to yield you 12, positive 12, okay, because you're getting rid of 3 -4s, okay, so whittling down your debt. Quadrant 4, picking 5 -4 cards is going to yield you -20. Okay, so those are some examples, but we've been talking about that all along the way. Okay, so here's what I want you to do here. This exercise 1 asks you to generate real-world situations that can be modeled by each of the following multiplication problems. Okay, and use your integer game as a resource. Okay, if you want to go ahead. So, yeah, multiplication of integers in the real world. Just give me a couple of, just give me a situation for each one. It could be very simple. Okay, very simple. You've done a little bit of this already. Actually, I think we had this on that quick quiz we took on Monday, the 20th of October. Some of you came up with some real interesting stuff. So I'm going to pause it here, so go ahead and take some time, pause, and then come on back. Okay, well, this isn't so easy, actually, all of these. I'm not sure what you guys did. Here are some that I came up with. This one here, -3 times 5a. I'm thinking my mom gave me 4 $5 bills for my allowance. That means, I'd have $20, but it doesn't really matter how much I have, but just the fact that I have $5 bills. I have 4 of those. This is the part. The next part is what matters, but I spent 3 of those bills. Okay, so I spent 3 of those $5 bills. Not I have. No, it should be now I have. Sorry. now I have $15 less in my wallet. Okay, so $15 less. That means I got rid of, here we go, this -3, got rid of 3 $5 bills, which means that I am now $15 less, or -$15. Okay, now I end up the day with $5 when I started with 20, and now I have 5. Okay. -3 times -6 times -3. This one was a little bit harder for me. I thought, I mean, you could do the integer game. Anybody do that? Okay, integer game. I got rid of 6 -3 cards, and now I have 18 points more. But I'm not sure how real life the integer game is. I'm not sure if we're going to be playing that outside of our classroom. But anyway, I decided to pay back my $18 debt. Okay, so this $18 debt is going to be negative to my friend in $3 installments over 6 months. So, you know, I'm every 6. So for 6 months, I'm paying back $3, and at the same time, you know, my debt is going down. Okay, my debt is going down. So every time I pay them $3, my debt is going down by $3. So it starts out as -$18. When I pay back the 3, now I'm down to -$15. This is going to be over the course of 6 months. Now I'm down to -$12. Okay, and you can see how this is going. Okay, so I'm paying $3 every month for 6 months, and is that going to get me down to 0? It should, right? Yeah. Let's start 18. Yeah. Oh, this would actually be month 1 right here. Month 2. Yeah. So that'll get me down to 0. But you can see my negative value as far as my debt is concerned. Okay, as far as my debt is concerned, is going down. So I'm actually increasing my money there. I'm actually getting a plus value. Okay, because again, I'm getting rid of a negative. Okay, 4 times -7. This would be, you know, my mom was on many diets. She doesn't go on diets anymore, but she was on a diet where her goal was to lose 7 pounds. You know, hence the -7 7 pounds per month for 4 months. So every month she is going to lose 7 pounds. Okay, which means that she would have lost 28 pounds. That would be a -28. Okay. Alrighty. So, not sure why that's there again. But anyway, here's our lesson summary. I don't know if you can see it there. Okay. So to multiply signed numbers, excuse me, multiply the absolute values to get their absolute value of the product. The sign of the product is positive if the factors have the same sign, and negative if they have the opposite signs. Okay, this is something that I think we have known for a long time. I like, you know, using the integer game or those integer cards to model it, because to me it seems to make a little bit, hopefully a little bit more sense, a little bit of something that you can attach it to. Because again, this past Monday, the 20th of October, a few of us had a couple hiccups and little like, oh, wait a minute, oh no, wait a minute, it's not negative, it's positive, because it just looks really weird. But if we have something to attach it to, hopefully that'll cement it more in our minds. Hey, this lesson was under 30 minutes, so I want you to congratulate me when you see me, and hopefully I can continue to do this with the next 4 for this week, or 3 more for this week. Okay, good luck. Let's see, most of you did the exit ticket, so go ahead and finish your problem sets. Okie doke. All right. See you when I see you.